All right, this one goes out to Gabe, but this is the instructions on how to make a graph on Excel. First thing you do is input your data complete with titles and headers. So I'm doing dataset 4 on the worksheet, and the X variable is time in units of seconds, while the Y variable is V, velocity, in units of meters per second. You're going to input your data, 0.3. And then put in your V's. Now since this is regular, remember the fill function, once the computer sees a trend, you can basically highlight it, use the bottom right corner with a black plus, and it will autofill for you. Take your data, highlight it all, insert a scatter plot, and then see what the graph looks like. And in this case, I can tell right off that it is curved. It is curved in this direction, and the X is going up fast, the Y is going up slowly. If in case I want to check it, I'd right click on the data point, add a trend line, and then display the equation and the R squared value. R squared is 95, it's not bad, but it's not good, and I can tell that this is not a straight line. I need to square the Y values, so without deleting my text, I don't need this equation because that line does not represent anything. I know I'm going to square the Y values. So in this case, I know my X column remains the same. I'm going to copy it and paste it. And then my Y column has to be squared. Now, if I'm going to square this, I'm going to start and take a second and make sure that my headers are there. Oops. Chart, design, quick layout, number 1. This is time in seconds for my X, time in seconds. This is velocity in meters per second in my Y-axis. Okay. I don't have the trend line because I don't need it. I can tell that's curved. I can tell it's not straight. Now, over here I need to square the data. Before I square it, I want to make sure that my header makes sense. If I square V, it's V squared. Okay. If I square the variable, I need to square the units as well. Meters per second goes meters squared per seconds squared. Okay. At that point, to program in a formula, you hit equals. That all gets blank. I can't click on anything up here, but then this function stuff shows up. Equals this value squared, and I hit enter. It advances downward. 10 squared is 100, but I'm going to take the bottom black plus, fill those in, and double check. 80 squared is 6400, 30 squared is 90. It did the math right. Again, highlight everything. Whoops. Insert a scatter plot. Click that in there, and I can tell right now that's a straight line. Quick layout number 1 gives me the axes. And basically what I'm going to say is this is now, X variable is still time in seconds. My Y variable is velocity squared in meters squared per seconds squared. Okay. This header and that should be the same. This and that should be the same. If I did squared my values, I should square my variable. I should square my units. At this point, I right click on the data. I add a trend line. It's going to be display equation, display R squared value, and that's my equation. Okay, this is perfect data. It's a 1 R squared value. Here's the tough part people have been asking about. I substitute in my Y and my X. Y in this case is V squared. That is the variable of the Y axis. V squared. Okay. My X variable, I'm going to put a couple spaces here and an asterisk to say this is Y equals 333 times X. I'm going to put that times in there just to separate these two. So I can take that X, I'm going to replace it with T, lowercase t. Now, any number must have units on it. The variables V and T do not need units, the numbers do. The slope has units of meters squared per second squared divided by seconds, or, parentheses, meters squared divided by seconds cubed. Close parentheses, and I now have the Y equals M, complete with slope, times X. X is here, Y is here, slope is that. If there's a Y-intercept, it just gets units of Y, and this is a finished graph. Now, remember, there are 3 kinds of graphs you can see. There is the inverse, where it goes this way, Y and X, in which case you're going to plot Y versus 1 over X. There's the exponential in x that's this way, where y is going too fast, x is going too slow. That means that x squared will give you a straight line. And then there is the exponential in y that looks like that. Y and x. You're going to do y squared. Please see me if you have any help or need any help, and that is the assignment.